Okay, before we start the new lesson for today, which is really going to be about this, about absolute values and absolute value functions, um, we're going to go back in time to this because I think it's actually a lot harder. If I have a curve, and that curve looks something like this, do you get that I could find quite a few different slopes depending on which points I chose to pick? All right, well, if I choose to pick this dot and this dot, then it might have this slope, as opposed to this dot and that dot, it would have a steeper slope. Anyway, the point is, it depends. Depends on what? Depends on the interval. So in this case, between 2 and 3, can you imagine I might say that's 2 and that's 3, or that's 2 and that's 3? All right, so you're finding the slope in there. Would you please find the slope? But I got to give you the equation for it, right? All right, so let's say this is negative x squared plus 3x minus 6. And again, I'm not saying it would look exactly like this curve. I was giving you a general example. What you're finding here is what's called the average slope. The average slope of this between 2 and 3. This should be a pretty happy place. Can you start off for me, Mr. ML? You're finding f of b or f of a to start with. Okay. All right. And what'd you get? Haven't actually got this done yet? Keep cranking it out. I'll come back to you on a different one. All right. Miss LP back there with the water bottle. What did you get when you stuck a 3 in? Okay, I'll let you pass on this one for your Schoology issues. Get caught up and I'll call on you in a minute. How about you? What do you think? Did you do f of 3? And what'd you get? All right, because that's negative 9 and that's positive 9. They cancel and you just have negative 6. Excellent. So we have negative 6 minus, now I got to do f of a. Did you already do f of a? What'd you get? And I was putting in a 2 here and a 2 here, and you got negative 4. Anybody verify the negative 4 there? Okay, good. And then we put it over b minus a, which in this case is 3 minus 2, which works out really nice because then you're just dividing by 1. So it's really just negative 6 minus 4. Uh-oh. Sorry, hold on. 3. Oh, so you're saying this was minus negative 4. Thank you. Okay, minus negative 4. Okay, I gotcha. Then it's negative 6 plus 4, which makes negative 2 divided by 1. Negative 2 divided by 1 gives me negative 2. And I found the slope. I found the slope of this function. Is that just the slope of this function? Just that one part of the function. Good. So if our function, would you agree it's generally an upside down parabola? What also could you say about it just with a quick glance? You can see that the what is what? What's that thing? That's the y-intercept. The y-intercept is at negative 6. Okay, so it's an upside down parabola with the y-intercept at negative 6. Do you get it? Must look something like that. Okay, and then I said that the slope between 2 and 3 came out negative. All right, if I say, well, depends on what I say 2 and 3 are. Okay, let's make this negative 6b a little further down here. All right. Oh, I know what's going on. There's another way to have the y-intercept at negative 6, and it's like that. So now I can have a negative slope. Otherwise, I was like, wait a minute. If I have this y-intercept at negative 6, and I do between 2 and 3, it's going to have a positive slope. See what I mean? But if I drag it over the other way, it must be like this, where its y-intercept is negative 6. Then when I go to 2 and 3, and I extend them down here, it'll have a negative slope. Okay, cool. All right. So if you picked other intervals, of course, you could even get this to have a positive slope. Like if you picked between here and here, You could make it have a slope of 0. How? If you pick the right interval, like went like this. Oh, I missed. I could touch that spot so that these two will be identical. There. If I use that interval, I'd have a slope of 0. Okay, good enough on that. So what's today about? Really, absolute values. Tennis ball lab is something that we're going to do as a part of this unit. Some people do it as a lead into the unit. I'd rather teach you a little bit first and then have you do the tennis ball lab. It's about quadratics, and I want you to just think about why. If I throw a tennis ball up, why do you think it's going to be about quadratics? It makes a nice little arc. Yeah, it makes a parabolic flight. Okay, but one thing that that is not actually happening is if this is the person throwing the ball, this is not how far away the ball is from them. If I make this little graph, what is that spot right there? It has to do with hitting the ground, but it is not where the ball hit the ground. Yes? Yes, this is the time it takes for the ball to hit the ground. And we tend to be visual people, so we think we're seeing the flight of the ball here. We're not. Because the ball could be going, this graph could represent a ball that is thrown straight up in the air. Straight up, and such that it even hits you on the head when it comes back down again. See what I mean? And this distance here is not really a distance, it's a time. This is time, and this is height of the ball. And so this graph seems like this is how far away it is from you when it touches, but it's not at all. It's a time when it hits the ground. Okay, so we will be doing the tennis ball lab, which basically is you throw the ball up, try to throw it straight up, and you kind of just get a feeling for how fast you threw it, and then you'll be able to actually, just from that one little time, how long it was in the air, you'll be able to figure out how fast the ball was going and how high the ball went. That's kind of cool to be able to do that just from timing. Now, it's subject to this painful reality. People are very bad at timing, especially short time zones. Like you get your friend and you to time like how long, I don't know, a ball was in the air, you might be off by a half a second, and which is massive when it's only in the air for a second. And one person says it was only in the air for half a second, the other person says it was in the air for a second and a half. People are way off on their timing. Okay, so I get some of you guys are going to be off on your measuring because you're not going to have it timed. Well, one of the ways you can overcome that is to take out the human element. There's an app for that. Has anybody seen the app that can do the ball in the air kind of thing? Is anybody, do you know what it's from?
My sister used it.
Okay, in which class, do you remember? Was it physics maybe? Use it in physics? Okay. And that can take the human element out of like when do you start, when do you stop, because you can kind of back up in time and line it all up and know when the ball got released, and then when the ball hits the ground, you'll be able to know those 2 times for sure because you have it in the video. But anyway, the tennis ball lab will be happening soon, and I just wanted to give you a little intro to it. It'll, of course, follow the format for all labs. All right, this is our new thing for the day, and it's just a reminder that absolute value graphs can be moved and flipped and all that stuff. Do you get that this would have started as an absolute value, which is a V-shaped graph? Does that ring a bell? Except this one got moved. I always start on the inside, so it got moved where? Right 2. And then you go to the outside. This 4 over here really annoys me because people think that the sign after it goes with the 4, like it'd be even worse if that was a minus sign there, that people think it's a -4 and it's not. That 4 would really be better suited to over here, and then it can join up with this -1. And then together they make what? 3. So do you get, I could have a 3 over there instead? Does that make sense to you? Okay, now I can say that my parabola went right 2 and up 3 and stretched. Does it matter? It does. Not every time, but it does matter that you follow the order. So on the outside, are you supposed to multiply first or add first? Well, you trust it. You do it in the normal order on the outside. What's normal? Multiply or add? What's first? Multiply is normal. Okay, so I should now do my vertical stretch. You get my V shape then. It's a lot steeper because it's got to be 3 times taller. Every spot, like this height and this height, that's probably only 2 times taller. Steeper. There. My V just got stretched, and then the last thing is it goes up 3. If that's all there was to it, this would be higher algebra. So it's pretty easy. All right. Now, wait a minute. It says solve for x, though. If we wanted to solve this for x, that's what the picture looks like. What does it mean to solve for x? That means we set it equal to 0. Like if there was a y equals here, now we set it to 0. What does it mean to set something to 0? If you want the y-intercept, you set x equal to 0. So if you want the x-intercept, you'd set y equal to 0. All right. So tell me, if this graph is really here, then what's its x-intercept is where y is 0. What's its x-intercept? Doesn't look like it has one to me. All right, so then let's solve this thing and try to figure out what happens when we solve it. All right, so if we're going to set it equal to 0 and just solve it, see where the flaw in our reasoning is, or either there is no answer, or I'm going to subtract off 3 now to get rid of this plus 3. This is already gone. This is already gone. We changed them into a plus 3. Now I'm subtracting 3. I have negative 3 equal to 3 times the absolute value of x minus 2. Do you see why that's not possible? I want you to think about that. Why is that not possible? You can't get an answer for that. Yes, ma'am. Yeah, this will have to be positive. And you take 3 times anything that's positive, how could it be negative? And we're not used to the answers that don't exist, but there are equations you cannot solve. There's no answer for this. It's like asking the question. We showed you where the graph was, right? I showed you where the graph was. It was like this. Do you get why it can't have an x-intercept? So you can't, if you set y equal to 0, which is where y would be over here, you won't be able to get one, and that's because when you actually try to solve it, you can't. Now, could you even do it with imaginary numbers? Could you do it with imaginary numbers? That implies the square roots. Did we ever do a square root when we are solving this problem? No, we don't do a square root. So you would not say that this has imaginary roots or imaginary answers because there was never a square root of a variable. Do you remember why when we did the square root of x squared, we got an absolute value out? The graph kind of looked like this. But you have to do the square root of a variable to have that happen. All right. That got kind of deep there for a minute. Absolute values are really simple, though. One of the things on the ACT, I bet you a lot of you couldn't tell me, and yet you're smart, but you maybe have forgotten this, is the definition of an absolute value. What is an absolute value? A lot of people say, oh, it's makes the thing positive. You know, yeah, that's true, but it's not what an absolute value is. What is the absolute value? Yes. The distance the number is from 0. So one of the things, if you look in the list of ACT topics that they can test you on, one of them says understanding what an absolute value is in terms of a distance. And it is the distance from 0. Okay, so when they say absolute value of this, it means how far is it from 0. And absolute values are distances, and that's why they can't be negative. Get what I'm saying? You would never say to your friend, how far are you from the bank? And he says, negative 4 miles. It doesn't make any sense, you know? Like, if he was in the bank, he might be snarky and say, I am 0 miles from the bank, right? So it could be 0 distance is a possible thing. But you're not going to say a negative distance. All right. So there's a bunch of properties to absolute values that you may not have known before. Did you know you could break them up into two things that are multiplied? They're a lot like square roots that way. Like if I had the absolute value of 20, would it make sense to you that that would be the absolute value of 4 times the absolute value of 5? Does that make sense? All right. And if you want to put it to a power, you can have the power on the inside or the outside. And it throws in this little whenever that's defined. Why? Because if they're asking you to do something impossible, it still won't work. So in other words, this kind of thing, a to the third, would equal absolute value of a to the third. Unless a is not possible. If a is some weird impossible thing, like what? Like I. Things that aren't defined. All right, and this one says it's fine to divide them into two absolute values, provided the bottom part is not 0. Why? Because you can't have dividing by 0. So these rules always just kind of remind you of things like the exceptions. Like, oh, by the way, you can't let it be 0 on the bottom. Okay, the absolute value is 0 only if x is 0. That seems like so logical, but mathematicians will define things very carefully. They want to cover all the exceptions. Okay, and if c is bigger than 0, it's saying that the absolute value will be x equals c or x equals negative c. Do you remember doing that? That's like this. Wait a minute. Sorry. Absolute value of x equaled 5. You remember how we broke that into x equals 5 and x equals negative 5? That's this property at work. When you do absolute values, you break them into two of them. And last, if c is less than 0, as in, is it the absolute value thing that you're coming out to is negative, then there will be no solution. That's what we just experienced there in that other problem. All right. So, bottom line, absolute values, you break them into two things. We've practiced this on the top 20 so that this day would be easy. 3x minus 1 equals 6, and 3x minus 1 equals what? Negative 6. It's right off that property that we just said a second ago. And if you didn't ever get this one on the top 20, there's probably one or two people where this is the moment they finally get absolute values. Cool. Get them down now. So then I just add 1 to both sides. 3x equals 7, x equals 7 thirds. And add 1, 3x equals negative 5, x equals negative 5 thirds. Some people that were in the old mode of using plus and minus 6 will get this all messed up because they'll think the answers are plus and minus whatever, but it's not. You got to have two separate equations. Here's the main thing I see people doing wrong. They say, well, I did everything you did, I just did it faster because I started by adding 1 right away. Do you see a person thinking that that might work? It doesn't work. You got to split it into two equations first. Otherwise, you're going to get one of those answers, and then they try to slap on a plus minus at the end. It doesn't work. You can't start with the adding 1. You got to get it split first. Then, unfortunately, people think I said you always split them first no matter what. Actually, you got to get this stuff out of here, get it down to just an absolute value, and then you split it. Okay, so math is never that simple. So we got to subtract 3 first here. Then I've got negative the absolute value of x plus 5. That's okay to do. Negatives on the outside are fine. 1 minus 3 is negative 2. Now can I split it into two equations? Nope. One more thing to do first. Divide both sides by what? Or multiply both sides by what? Negative 1. That gets the negative off of here and it becomes positive. Now can I split it into two equations? Yes. And this is what I call get the clump alone. This is the clump. You got to get that clump alone first. And then you can proceed with solving it. It isn't just those. It's when you have a square root. You have to get this clump alone before you proceed. Why? Because those clumps are really grouping symbols. They're like parentheses. Okay? And you do that part last. I don't know if you've ever noticed this. Sometimes this is a revelation for people. I could be the first to tell you. Why do we do the parenthesis part last? Because I don't know if you noticed this, but you've been doing the order of operations backwards forever. Do you get that the first thing we should do here is subtract 5? Why? Why should we divide by 2 first? Because we do this in the opposite of the order of operations. When you're solving an equation, you're going in the opposite of normal order. Do you get we don't start with getting rid of the 2? But in the order of operations, wouldn't the 2 normally be first? All right, so it's all about when you're solving an equation, you're doing it in the opposite of the normal PEMDAS. So you do start with your add subtracts, which are your last things. And then you proceed on to do your multiply and divide stuff. Well, now you're in stuff that's got a parenthesis or a grouping symbol, like a square root, that's a grouping symbol, or an absolute value, that's a grouping symbol. Those are these guys. So they're the very last things that you should do, which is why you have to start with your add subtract stuff, do your multiply and divide stuff next, then you can handle your parentheses last. That's why you start by subtracting 2. And then you get multiply by -1 or divide. That's a multiply or divide thing. And I'm going to divide by -1 this time, just to make the point. And then this one, I hope at this moment that you won't get trapped into just finishing the problem and getting the 2 answers, because why? This one's impossible. Did you get how it would have been really easy to just keep going and split it into 2 and get 2 answers that are completely false? They don't work. So don't get trapped into that. You got to watch out for absolute values equaling negatives, because that's not possible. All right. Cool. So then, typical questions today are kind of laughably easy until they get hard. But you start with absolute values. Take the absolute value here, and what does it do? Come on, it moves it where? Moves it right 3. Okay, how about this absolute value here? Moves it down 3. This absolute value here, ooh, it does a whole bunch of things. Okay. If we had to do all of this stuff for an absolute value, which you could be asked to do on a test, go to this slide that's got the yellow on the right and the green on the left. I think these statements are super powerful. The x-intercept is where, well, don't say where it hits x. The x-intercept is where y equals 0. So I can just go through and put, well, that's where y is, so I could put a 0 there, and I could solve it, and I could find my x-intercept that way. Could I graph it and find the x-intercept? Yeah, that works too. But the y-intercept is where what? X equals 0. I could put in a 0 and figure out that that's 4, and the absolute value is 4, and then 4 times 3 is 12, and then 12 minus 4 would be 8. So I know my y-intercept, which is where x is 0, comes out to 8. Domain and range, well, if I had a picture up here, it'd probably be easier. Here's my V shape that got moved to the left 4, and then got stretched to be 3 times as tall, and then got moved down 4. Now, generally speaking, can you tell me the domain and range from seeing a picture? To me, as soon as you get the picture, it's easy to do domain and range. Domain's all reals because it's going both directions like this. Range is not all reals because it stops wherever that is. In this case, it's been moved down 4, so it would stop. I was up a little bit too high there. It stops right there, so therefore it's from -4 to infinity on the range. Increasing, well, it's increasing on the right side of that line. It'd be decreasing on the other side, to the left side. And then absolute min is like the low spot. There it is. There's my low spot. I hope that that's all, but it should be pretty easy for you. Now let's say you're on the test and you're like, crap, I can't remember how this works. I'm getting confused on what order to do it in. What can always save the day? on graphing. I'm sad that only one person couldn't whisper that. XY chart. That's your best friend on graphing. You should do an XY chart every time that it really matters, because you can make sure you didn't screw anything up by going back to the old school XY chart. It's one of the reasons part of the top 20 most important algebra skills for this class. Let's make a chart for an equation. So if I want to pick numbers, I can stick in strategically. I'm going to choose wisely. I'm going to choose -4 because that'll make that whole part 0. So -4 goes in, and I get 0 times 3 is 0, minus 4 is -4. -4, -4, and I actually happen to hit the vertex right there. I wouldn't necessarily know that until I put in a few more points. And I could put in like, oh, -3. And then I put in the -3, and then I figure out that that's 1, and the absolute value of that is 1 times 3 is 3. 3 minus 4 is -1. -3, -1. It's right there. And I might not know this yet, but that's the bottom of the V, and the other part's going to go up like that. And there we go. Cool. The XY chart can save the day for you today, anytime you have graph. All right, that's it. Here's the assignment. Let's cut it down to be a more reasonable size. And I'm going to grade last night's, because some of you are saying he never grades the homework, but I'm going to today. So here's the assignment for tonight, but I'm going to cut a few out. Let's cut out 2 and 9. It's kind of weird when you mix absolute values with quadratics, but it does work, and I want you to see that. And I think all 3 of these are good for you to see, so we should do all of these. Again, you just split this into 2 parts. X equals 12 minus x squared, and x equals the opposite of all that. Don't forget, since there's a bunch of stuff over here, don't just slap one negative on it. You put a negative around all of it. You might want to write that to start. There's your 2 equations. Okay. On this page, I think we should do, this one's kind of cool. This one's kind of annoying. Let's just do this one, because it's identical to 19. What are you going to do if there's absolute values on both sides? What? I'll let you figure that out. It's going to be good for you. It's a little bit of just a little stretch. No, that's not super hard stretch, but you'll figure it out. All right, and then this last part's about graphing. I don't need you to do a lot of these. We did so many last year that you should be like pretty solid, pretty quick. We'll just do 22 there. And I don't feel like we need to do these 2 for now. I might actually do them in class tomorrow, but so we're going to stop and not do this either. That's it. So to sum it up, you're going to do problem 22. You're going to do problem 16. You're going to do problems 12 and 15. And 1 and 5. That makes it about 8 questions, which is pretty reasonable. Now we got a boatload of time left, which is good because we're going to spend some of it grading last night's homework. So find last night's homework, and I know some of you slacked and didn't do it because I'll blame myself. I haven't graded it in a while, and so maybe you start thinking, but should you really be doing it because I'm grading it? No, the reason you should be doing your homework is because you'll touch it one more time. You'll remember the stuff we taught you better. And of course, practicing for the test will help you do better on the test. That's why you should do the homework, not because I'm going to grade it or not. I'm going to put it to you straight. There's a fair number of you that next year, you're not going to grade your homework. And you're going to go, I'm not doing this. I got too much other stuff to do. And your grade will go down like a full grade. Because if you don't do your homework, it will make a difference. And the reason, it's math, it just makes sense. If I tell you something right now, Bob, Ichabod, server, and you might remember it in your short-term memory for 7 seconds, and then it might even go to medium-term memory that at the end of the hour you still know it. But by tomorrow, you'll have forgotten that. But if you repeat it just one more time tonight after school, you remember that what I just said just once, that's the touching it in your homework part, then you'll remember it again the next day. Okay, but otherwise you're just going to forget it. That's why homework works so well. That's also why I don't need to assign you a million problems. I just need to have you touch it once tonight. All right, and that's one of the downsides actually of doing your homework in class, totally. If you do all your homework in class, is you're not giving it enough time to touch it again, so you might forget it before tomorrow. Might actually better if you did some of your homework at night, at home. All right, that's all I got for you for today.